Alright, so today we're going to be talking about symmetry and linear functions. So let's make a little t-chart here. Put a line down the middle. We'll say the left side is linear functions. And the right side is non-linear functions. So linear means line. So of course, if a function is linear, it is going to form a straight line. So the first point is forms a straight line. When graphed. And if something is nonlinear, that means it does not form a straight line. So over here, we're going to put not. Oops, well, I should probably say does not. Does not form a straight line. So that means this is going to be something like a curve. It's not straight, it's a little bit bent. So I just put curve in parentheses there. So on the left, a straight line. On the right, not a straight line. The next point that we want to have is the exponent. Exponent is the number in the clouds of a linear function is going to be 1, or the invisible one. I'll explain that in a minute. And over here, the exponent is not 1. So it's either 0 or it's going to be higher than 1. So over here to the left, a linear function, the x is just going to be x to the first power, or the invisible 1. And over here, it's going to be x squared or x cubed, something higher than 1. So we'll get to that in a minute, like I said. The next point is that linear functions can be written in y equals mx plus b form. So they may not be presented that way, but they can be changed around to look like that. These ones do not. So they are not written in y equals mx plus b form, which you'll remember is called slope-intercept. So those are some points about linear and nonlinear functions. Now we're going to do some quick examples of them. So on the left, 3 examples of linear functions. Y equals 3x minus 1. F of x, remember we did f of x, equals 1/2 x. And 4x minus 5y equals 16. So let's look at all of these. The first one is already in y equals mx plus b form, so it's perfect. The second one, there's no b, so you could say plus 0, or you could just look at it with that one. But the exponent here, the exponent is 1. There is no exponent. So that one is perfect as well. And the bottom one, even though it doesn't look like y equals mx plus b, it can easily be moved around so that it does. So those are all linear functions. When they're graphed, they form a straight line. Over here, we have y equals ln, or natural log of x. Y equals x squared minus x minus 5. And x plus xy equals -8. All of these will not form a straight line when they're graphed. So first, natural log. If you don't know what that is, you don't have to right now because it does not form a line, and that's all you need to know. The second one, there is an x squared right here, and we can't have that. Remember, the exponent has to be just a 1, or just invisible. And the bottom one is just crazy. There's a lot going on there. So obviously, that one doesn't work. So let's look at some examples. This is example 1. And the question is, is this function linear? So I'm going to give you a couple different functions, and you're going to tell me, is it linear? Is it not linear? Part A, 3x plus 2y equals 8. Well, this can probably be put into y equals mx plus b form, so let's see if we can do that. Here we want to get the y alone, so let's move the 3x to the other side. Minus 3x cancels. We have 2y equals negative 3x plus 8. Almost there. And divide everything by 2. Divide by 2, divide by 2. So now y will equal negative 3/2 x plus 8 divided by 2 is 4. So yes, this function is in y equals mx plus b form. So yes, it is a function. Let's look at part B. This one is f of x, a function of x, is 2x minus 5. This is also in y equals mx plus b form, and the highest exponent is an invisible 1. So yes, this is also a function, a linear function. Part C, y equals x squared plus 2. Right off the bat, this exponent is higher than 1, so this is a no. And we have two more. They're both graphs. They don't have to be perfect. I'm just going to do a really rough graph here. So make my graph. And part E is also a graph, so I'm just going to do it right next to it and make another one. Part D and part E. So part D looks like this. And part E looks like this. So you can see here, one of them is definitely a linear function and the other one is definitely not. E forms a straight line. So this one is definitely linear. Yes, sirree. Part D is a curve, and remember, non-linear functions formed curves. This is not a straight line, so no. So that is linear functions. Pretty easy. Does it form a line? Yes or no. And the next thing we have is symmetry. There's two types of symmetry. The first one is called line symmetry. So for line symmetry, basically each half of the graph, maps exactly to the other half. This is the symmetry we've always known. It's also called reflexive symmetry. Basically is, does it match up on both sides? So the question I ask myself here is, can I fold it over to match up? Can you fold the graph over on top itself in half, and will the two sides match up? If it does, then you have a line of symmetry. The line of symmetry. And that is the line dividing the graphs, or the graph, into two halves. And it can also be known as the crease. So if you would fold it, where is the crease right there? Where do they kind of match up? So let's do a quick example. Draw a graph. I'm going to label to 5 on all the sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we have something called a parabola. It's basically just a curve right here. And the question is this symmetrical? Does it have line symmetry? And where is the line of symmetry? So can I fold this in half and it looks like itself? Absolutely. Where would the crease be? So basically you just draw a line to the middle, and there's the crease. And the equation of this line is it's on the x-axis, so it is x equals, and that is the point 3. So x equals 3. That is that line right there. So yes, it does have line symmetry, and the line of symmetry is x equals 3. The other kind of symmetry is called point symmetry. So let's go down here, and we'll write point symmetry. And point symmetry is if the graph can be rotated 180 degrees around a point and look the same. So the question I ask myself for this one is, will the graph look the same if you flip it upside down? That's what 180 degrees is. So here's the question. Does it look the same upside down? So you have line symmetry, which is folded in half. Point symmetry, flip it upside down. And just like we have a line of symmetry, here we have a point of symmetry. And that is the point that acts as the center of rotation. So it is where you rotate that around. We have one example for this, and then we're done. So I'm not even going to label this with numbers. I'm just going to draw it, and here is a rough little sketch of a graph. Okay, so here's our graph. The question, does it look the same upside down? Well, if you take your paper and flip it upside down, then yes, it does. Or take your head and flip it upside down. It does look the same. Where, if you were to spin this around like a spinner, think about Twister. You spin the spinner at Twister. Think about where would the center point be. And for this example, it's right here at the origin. Now, it's not always at the origin, but this time it is. So the point of rotation, or the point of symmetry, is 0, 0. And you can see that if you were to spin this around, then it would have symmetry around that point. So here's what you're going to do for your project. I have given you a piece of graph paper. And what I want you to do with that graph paper is we're going to make a jack-o'-lantern. So this was my little example. Here's your graph paper. What we're going to do is you're going to actually fold the paper in half. You're going to make whatever jack-o'-lantern face that you want to. This is kind of like cutting a snowflake. If you've ever folded something in half and cut a snowflake, it's like that. So cut out pieces to make a jack-o'-lantern face. You must have at least 5 shapes. So I have 6 shapes, I believe. 1, 2, 3, 4, 5, 6. Yes, I do. But you only have to have 5, so choose wisely. And after you do that, so fold it in half, cut the shapes that you want. Here I used all kinds of shapes. I used a circle, I did a triangle, rectangle, and then some trapezoid shape here. But you can make whatever shapes you want. After you do that, open it up and see your face. Make sure you have 5 different shapes. And then I want you to draw a line through the shapes on your paper and label the line of symmetry. So here, the x, the line of symmetry, was -6. I went over to -6, and here it is +6. Here it was 4, -4. Here it's 0 right through the middle, like this. And here it's also 0. But yours might be different. I just want you to draw those shapes and tell me where the line of symmetry is. You can either take a picture, turn it into this assignment, or you can bring it to me next Monday. But that's all from me, guys. I hope you have fun with this, and I'll see you later.